Imagine a world choked by a silent killer, not a virus or a monster, but oxygen. This wasn't science fiction, but a very real event that unfolded billions of years ago on our own planet. The Great Rust, as it's ominously nicknamed, wasn't caused by a rusty nail, but by the rise of the first eco-terrorists. Well, not exactly terrorists, but we'll get to that. This ancient disaster offers a chilling glimpse into how seemingly positive changes can have devastating consequences. Sound familiar? If you're someone who prepares for the unexpected, even the seemingly impossible, then buckle up, because this video tells a tale from Earth's past which has some eerie parallels to potential future scenarios. The rise of cyanobacteria. Our story begins 2.4 billion years ago, when life on Earth was vastly different. Imagine a world bathed in a strange greenish glow, devoid of the oxygen we breathe today. The atmosphere was thick with methane, ammonia, and carbon dioxide, a noxious cocktail that would be lethal to us today. Yet, in this primordial soup, life thrived, albeit in a form alien to our modern understanding. Single-celled organisms, primarily archaea and bacteria, ruled the microscopic world, relying on chemical processes far different from respiration as we know it. Then, enter the stage our unlikely protagonists, the cyanobacteria. Now, calling them eco-terrorists might be a bit dramatic. They were just trying to make a living, but the impact they had would forever alter the course of life on our planet. These tiny, single-celled organisms possessed a revolutionary ability: photosynthesis. Through this process, they used sunlight, water, and carbon dioxide to not only fuel themselves, but also, unintentionally, produce a gas that would eventually transform the planet: oxygen. These early photosynthesizers weren't the sleek, green machines we see in plant life today. They were simpler, unicellular organisms, likely resembling blue-green algae of our modern oceans. But their innovation, the production of oxygen as a byproduct of photosynthesis, would have a profound and unexpected impact on the existing ecosystem. Imagine a scenario where you introduce a completely new element into a carefully balanced environment. That's essentially what happened with the rise of cyanobacteria. For most of Earth's early history, the atmosphere was devoid of free oxygen. These early life forms thrived in an oxygen-free environment, relying on processes like fermentation and methanogenesis to generate energy. However, the oxygen produced by cyanobacteria was a poison to these dominant life forms. The Great Oxidation Event. Oxygen rising, life dying. The cyanobacteria's invention of photosynthesis, a seemingly benign act, unleashed a silent storm that would forever alter the face of Earth. The oxygen they produced, initially used up by chemical reactions in the oceans and absorbed by rocks, began to accumulate in the atmosphere. This rise in oxygen, slow at first, would eventually reach a tipping point, triggering a cataclysmic event known as the Great Oxidation Event. While oxygen is the very breath of life for us today, for the dominant life forms of 2.4 billion years ago, it was a deadly poison. These early organisms, known as anaerobes, had evolved in an oxygen-free environment and lacked the protective mechanisms to deal with this new threat. Imagine introducing a highly reactive chemical into a delicate ecosystem. That's essentially what happened. Oxygen is a powerful oxidizer, readily reacting with other elements. One such reaction, earning the event its ominous nickname, was the Great Rust. Iron, a common element in the Earth's crust, readily combined with oxygen to form iron oxide or rust. This not only locked away iron from biological processes, but also served as a visual reminder of the dramatic shift occurring in the planet's chemistry. The rise of oxygen wasn't just a cosmetic change to the atmosphere, it was a full-blown ecological disaster. The increasing oxygen levels proved lethal to most of the existing life forms. These anaerobes, lacking the necessary adaptations, were poisoned by the very air they breathed, or rather didn't breathe. This mass extinction event, the first of its kind on Earth, wiped out a significant portion of the microbial world, forever altering the trajectory of life on our planet. A glimpse into a future we can avoid? The Great Oxidation Event serves as a stark reminder of Earth's vulnerability to drastic environmental changes. While the rise of oxygen may seem like a positive development, after all, it paved the way for complex life forms like ourselves. It highlights the delicate balance of our planet's ecosystems. Even seemingly beneficial changes can have unforeseen and devastating consequences. While a full-blown oxygen apocalypse might seem like the stuff of science fiction, the Great Oxidation Event offers valuable lessons for those who choose to prepare for the unexpected. The core principle of emergency preparedness lies in being proactive in planning for potential threats, even if they seem unconventional. Just as the early inhabitants of Earth couldn't have predicted the rise of oxygen as a lethal weapon, we too might face unforeseen challenges in the future. Climate change, resource depletion, and unforeseen pandemics are just a few examples of potential threats on the horizon. By understanding past environmental catastrophes like the Great Oxidation Event, we can gain valuable insights into how seemingly small changes can have a domino effect on a global scale. This knowledge allows us to be more proactive in preparing for potential disruptions, mitigating their impact, and building resilience in the face of an uncertain future. The Great Glaciation, a chilling side effect. The story of the Great Oxidation Event doesn't end with the mass extinction of anaerobic life forms. The rise of oxygen, while seemingly a positive development for the evolution of complex life, had another unforeseen consequence. It triggered a period of global glaciation known as the Huronian glaciation. This chilling side effect highlights the interconnectedness of Earth's various systems. The atmosphere acts as a delicate blanket, regulating the planet's temperature through a balance of greenhouse gases. One such gas, methane, played a significant role in keeping Earth warm during this early period. However, as oxygen rose in the atmosphere, it began to react with methane, a potent greenhouse gas. Imagine a scenario where you remove the insulating layer from a house. That's essentially what happened. The oxygen, acting as a chemical sink, scrubbed methane from the atmosphere, leading to a significant decrease in its overall greenhouse effect. This drop in greenhouse gases had a dramatic impact on Earth's climate. Without the insulating properties of methane, the planet began to cool rapidly, plunging into a period of global glaciation. The Huronian glaciation, estimated to have lasted for hundreds of millions of years, saw vast swaths of the planet covered in ice, a stark contrast to the earlier, warmer conditions. The Huronian glaciation serves as a powerful reminder that environmental events are rarely isolated. Preparing for one disaster might not be enough if it triggers unforeseen consequences. Just as the rise of oxygen, a seemingly positive development, led to a period of global freezing, so too can other environmental changes have cascading effects. A comprehensive emergency preparedness plan should consider the potential for chain reactions and domino effects. For example, a solar flare could disrupt power grids, leading to cascading infrastructure failures and resource shortages. By understanding the interconnectedness of various systems, we can develop plans that address not just the initial event, but also potential secondary consequences. This allows us to build a more robust and adaptable approach to preparedness, ensuring we're better equipped to handle the unexpected. The Great Oxidation Event, with its mass extinction and chilling glaciation, serves as a valuable cautionary tale. It reminds us of the delicate balance that exists within Earth's various systems and the potential for seemingly positive changes to have unforeseen consequences. Just as the rise of oxygen, a life-giving molecule for complex life, triggered a mass extinction and global glaciation, seemingly minor environmental disruptions today could have far-reaching and devastating consequences. The lessons learned from the Great Oxidation Event hold profound significance for those who advocate for emergency preparedness. Just as we prepare for natural disasters like earthquakes and hurricanes, we should also consider the potential for large-scale environmental changes. By understanding past events like the Great Oxidation Event, we gain valuable insights into how seemingly small environmental shifts can trigger cascading effects on a global scale. This knowledge allows us to be more proactive in preparing for potential disruptions, mitigating their impact, and building resilience in the face of an uncertain future. The Great Oxidation Event may be a story from billions of years ago, but its lessons resonate deeply in our present. This knowledge allows us to be more proactive in preparing for potential disruptions, mitigating their impact, and building resilience in the face of an uncertain future. By understanding how past environmental changes unfolded, we can better prepare for the challenges that may lie ahead. Emergency preparedness isn't just about stockpiling supplies for a short-term disaster. It's about building a more resilient and adaptable society, ready to face a future filled with unforeseen challenges. The Great Oxidation Event may be ancient history, but its lessons resonate today, urging us to be proactive in preparing for a future filled with both challenges and opportunities. Hope you liked today's video. Don't forget to subscribe and press the bell icon so you won't miss any updates.